right, well, let's go ahead and get started. Hello, and welcome to this Morpheus Tech Brief on sharing Terraform resources. I'm Martez Reed, Director of Technical Marketing with Morpheus Data. So for those that have worked with Terraform, one of the things that often comes up, depending upon the situation and scenario, is the need to be able to share data from one Terraform deployment to another Terraform deployment. There's a number of reasons why this commonly comes up from a Terraform standpoint. So one of the cases is a one-to-many resource reference. And so what I mean by that is there may be times in which you have a shared service, such as a VPC, subscription, whatever it might be, and information about that given resource or resources within that Terraform instantiation need to be made available to other resources that need to reference it. And so that then allows the ability for those downstream resources to be able to reference data from the upstream resource without the downstream resource having to hard code that information, as oftentimes it may be dynamic in nature, or simply you do want to be able to properly decouple the references between the two resources by not hard coding a given resource identifier in the downstream resource, which oftentimes limits the reusability of the downstream resource code. Another situation and scenario where this often comes up is if there are different code owners. An example in many large organizations that have adopted Terraform is that there are multiple teams utilizing Terraform to manage the various cloud resources. So as an example, you may have a security team that has created things like security groups, maybe some firewall configuration, a number of different things in their specific specialty or discipline. Those objects may often then need to be utilized for various different teams within the organization, such as a downstream application team that then needs to reference information from the Terraform code that the security team has created or defined. At that point, you then need to be able to reference between the various resources. Typically, it's going to be the downstream resource to the upstream resource. And then another aspect, similar to even the other two use cases, but more clearly defines what's going on from a more technical perspective, is that you have resources with independent life cycles. And so in the case of, let's say, a shared service, that is a potentially a long-running set of resources that aren't going to be spun up and torn down in comparison to, let's say, a downstream resource where maybe an app gets spun up, spun down, gets spun up, spun down very frequently, in which I don't want to couple the life cycle of those two instantiations together because one is going to be around for a while, another is more dynamic or ephemeral in nature. So at which point I have to decouple the Terraform instantiations, but I still want to be able to reference information from the upstream resource or the long-running resource in the more ephemeral resource to provide that good decoupling from a coding standpoint. And so we've mentioned what we're trying to accomplish from a Terraform standpoint is being able to access data that exists in one Terraform deployment, one Terraform instantiation, and then reference that in another deployment. Oftentimes, I'll refer to it as a downstream resource. So in the case of Terraform, there's a number of solutions that are available to be able to accomplish this. The first one that often comes up is utilizing Terraform Remote State. And so Terraform Remote State capability allows you to be able to look up or reference information about an upstream resource and then utilize that in the downstream resource. So one of the challenges with Terraform Remote State is the way in which it's going to access that information. And so in this example, we have the upstream resource is utilizing something like remote storage or remote state storage. Could be an S3 bucket, could be blob storage to save the state in a remote location. The downstream resource wants to access information about the upstream resource. So in this case, let's say it's a resource ID, very generic, 1234. the downstream resource needs to access that information to configure something in its set of resources. And so the mechanism by which it's going to grab that information when utilizing the Terraform remote state capability is that it's going to reference the Terraform state for the upstream resource to grab that information. It works well in terms of what it actually looks to accomplish, the goal being grabbing that resource ID from the upstream resource. The challenge or the problem with this solution is that it's grabbing the entire state. Challenge with that in particular environments is going to be that, number one, the Terraform state is going to hold potentially sensitive information, which is why we do things like restrict access to Terraform state, encrypt it so that where it doesn't exist in plain text on a file system or in an object storage solution such as S3 or blob storage. So the downstream resource is going to have access to that potentially sensitive data in addition to the resource ID that we have. So in our example, the data that is being shared is not only that resource ID of 1234, but our secret that is don't tell anyone. And so we got what we wanted, but we got more than we actually needed. And so that creates a problem in which that sensitive data could be exposed in a manner or fashion that you do not want. So in the case, if we take within a single team, it's not the worst thing in the world. But as we talked earlier about the possibility of this information spanning an organization or multiple teams within an organization, that now becomes certainly more problematic, in which maybe the security team has created a resource and one of the pieces of information in that instantiation is some sensitive information. And now a downstream application team or DevOps team or platform engineering team needs to reference that resource. And they don't necessarily need to have visibility into that secret that is now in the Terraform state file. And so this is why the Terraform remote state is actually a mechanism or method that HashiCorp documents as not the preferred method, given the security implications that I just described. The more recommended method is leveraging an intermediary storage solution. And so technically, the remote state could be an intermediary storage solution as well, given that the state is going to be in S3 or blob storage or some other location. But in the case of intermediary storage, there's a couple of differences that particularly stand out. So in this case, when I refer to intermediary storage, we're going to see solutions like AWS Parameter Store, Azure Configuration, HashiCorp Console, and then we'll touch on Morpheus Cipher in a few minutes, which is the core focus of this tech talk or tech brief. And so in the case of intermediary storage, what we actually want to do is we want to be explicit about what it is that we are outputting or making available to the downstream resources. So in this case, one of the things we could do is we could specify that, you know what, I want to take the value of resource ID, in this case, 1234, in the upstream resource, and I want to explicitly create a reference or place that information in an intermediary storage solution, such as AWS Parameter Store, Azure Configuration. And that allows then the possibility of a downstream resource to reference that intermediary storage and get exactly what it is that they need and nothing more. So that helps to reduce the issue of exposing more information from a Terraform state standpoint than is necessary. So in the case of the intermediary storage, we're saying we only want to grant access to the resource ID, and the downstream resource is only going to be able to grab that information from the parameter store or the intermediary storage solution. And so how do we do that within the Morpheus platform? With the other solutions like AWS Parameter Store, Azure Configuration, you're going to leverage those providers for Azure as well as AWS to create a resource that then saves the value, in our example of the resource ID, to the key value store or the parameter store, which can then be referenced later by a downstream resource. So, similar path, Morpheus platform includes the integrated key secrets storage solution, Cipher. So that is a mechanism that can be leveraged, similar to a number of the other solutions we mentioned, to hold data that can then be referenced by a downstream resource. So the Morpheus Terraform provider has added support for this method or solution in the 9.9.0.9.9 version of the Terraform provider and above. And so it provides the ability to be able to write data to the Cipher store, as well as to be able to read data from the Cipher store utilizing the Terraform provider for Morpheus. And so let's take a quick look at the architecture for such a solution from a Morpheus standpoint to better understand the various moving parts and how this might be accomplished. So in this example, we're going to utilize Terraform blueprints within the Morpheus platform to be able to simplify the interaction from a Terraform standpoint. So the first thing we're going to do is we're going to create a service account role for our Terraform service account. So the reason we're going to do that is the Terraform is going to need access into Cipher to be able to read and write data. In theory, you could also utilize the existing resource if you had other Morpheus resources that you were creating. But in this case, we're taking an example in which I might be creating resources in AWS, and I don't have an existing Morpheus instantiation within that code. So I'm going to add Morpheus provider to that code to allow me to then integrate with the Morpheus platform from a Cipher standpoint to be able to read and write data there. So we start off with the service account. The service account role can be very much pared down to simply having access into Cipher from the Morpheus platform standpoint. So being able to read, write, update, delete into Morpheus Cipher. So very much pared down. Service account role is going to be tied to a Terraform service account. In this case, simplified example, we're going to leverage a single service account to handle both the read and the write operations from a Terraform standpoint. What I'll then do is populate the Morpheus TF-var secret with the information, so those variables that Terraform will need to be able to integrate with Morpheus. Then the app blueprint, once I instantiate it, it'll then generate the resource and then populate that information into Morpheus Cipher in the designated location that I've defined. That then makes it available to a downstream resource that can then read that information out of Morpheus Cipher, certainly given that it based upon it having the appropriate level of access and credentials. And so that's where we have the same mechanism on the other side of having both blueprints have access to that service account from a Morpheus standpoint. In this case, they both have the same service account role associated with it. So that's the ability to both write as well as to read from the Cipher. So let's take a look within the Morpheus platform of how that looks. The first thing we'll do is we'll take a look at what some of the code actually looks like to be able to accomplish this. And so I've got a GitHub repository here with some examples of what that looks like. So in this case, we have the first component, which is the upstream resource that is going to write data into Morpheus Cipher for the downstream resource to be able to look up. So let's come into the output resource in our main.tf. So one of the things I've done is keeping the example very simple. I'm simply using the local file resource from a Terraform standpoint to simulate what it would look like from a consumption standpoint. So what we have here is we have a provider block in which I have the Morpheus URL, username, password. The Terraform provider does also accept access tokens. So there's a couple of ways to be able to authenticate from that standpoint. So what we have here is we want to be able to utilize this for reference purposes. So what we have is we have two local file resources. So in this case, we have content being added to the files, and then we have them being outputted to an MD5 hash. So we're actually grabbing the hash of the file content in this example. And so we have the resource here. So this is the important part from a Morpheus standpoint. This is how it's being handled. So we have the Morpheus Cipher Secret resource, and then we're specifying that we want the key within Morpheus to be example workspace foo_hash, and the value is going to be of that local file that we saw here. So what that's going to do is that's going to write the value into the cipher store. In the case of the Morpheus Cipher Secret resource, we do not see the preceding secret from a pathing standpoint. That's because we have specified that it is the Morpheus Cipher Secret, so it implies that it's going to be secret before or prefixed to the example workspace. And then similarly, we have another one in which we're utilizing or grabbing both hashes that are being specified. So if we come into the Morpheus platform, let's take a look at a couple of the different components. First one we talked about was the service account role within the Morpheus platform to be able to grant access. So in this case, I have a TB_cipher_role within the Morpheus platform. And so as I mentioned, the permissions that have been granted to this role are very, very much pared down. So in this case, only thing that I have granted access to is into Cipher. So this is literally all this role has access to is Cipher within the Morpheus platform. And so at which point I create the role, I create the user account. The user account then has the role that we saw associated with it. So similarly, so we see the TB Cipher role within the platform. So though we have the service account, we have the role that the service account is associated to. And so now we're going to take a look at the mechanism by which we would facilitate the creation of the blueprints. So let's come take a look at the blueprints within the platform. So let's take a look at the upstream blueprint first. And so we're utilizing a Git integration. So we saw our Git repository. We saw the working path is that output resource that we saw, got the branch of main. In this case, we have a TF-bar secret that we're associating with the blueprint. So this is what's going to allow it to be able to interact with Morpheus, to interact with Cipher, to write the data into the Cipher secure storage. So let's take a quick look at the TF-bar. So the TF bars will also be in Cipher as well. So we see our TF bars TB simple secret here within the platform. So that's what's going to allow us to be able to interact with Morpheus. Let's come take a look into provisioning and apps actually. So I actually have a current instantiation of it already running within the Morpheus environment. And so we can come take a look at the state file. So in this case, I do not have anything that is actually sensitive. Certainly, if there was actual sensitive information, this would be something that should not be shared. But in this example, we can see that we have a number of resources under management within the state file. So a couple of things in particular to look at is we see our Morpheus Cipher secret, and we're providing the value, which is that hash of the file that we saw. So the content that we're providing to the particular file from a Terraform resource standpoint is then being hashed, and that's what we're seeding into Cipher. Similarly, we have the other side here as well from a overall joint hash standpoint or hashes within the Cipher. And so we should be able to look in Morpheus Cipher and see under example workspace /foo_hash. So that value should exist in Cipher. And so we can see here that it does exist in Morpheus Cipher. So in this case, it's a hash. In the case of a real life example, it would be something like a resource ID or some other value that you then need to reference from a downstream resource standpoint. So the Terraform has run, it has populated Cipher with that information and that data to be able to allow it to then be fetched by a downstream resource. So let's take a quick look at the downstream resource from a blueprint standpoint. So configuration looks near identical to what we saw with the upstream resource, in that we're leveraging that same service account with the same role and then in this case, the exact same TF-bar secret, because we're leveraging the same mechanism to perform both the write as well as the read from Morpheus within the Terraform context. So if we come to provisioning and apps, we'll take a look at the downstream resource. So in the case of the downstream resource, we see that we have some data lookups. So let's actually take a look at the code to see what's actually going on under the covers. So we have the lookup resource, we have the main TF, similar block from a configuration provider configuration standpoint for the downstream resource. But in this case, we now see that we have data references to perform lookups on the values that were written into Morpheus cipher itself. So in this case, we are grabbing the example workspace foo_hash, which is in this case a single text value. And then we are grabbing the foo hashes within cipher as well. And so in that case, that is JSON encoded from a Morpheus standpoint. So all we're doing is grabbing the hashes, utilizing a JSON decode to be able to output that in a more human readable format. And so that would allow us to then be able to utilize those particular resources or that data in the downstream instantiations. So as an example, I could take the data from the upstream resource and then use it as part of the creation and management of resources within this downstream resource instantiation. So this case, it could be, let's say the upstream resource is a VPC, and in subnet configuration, the downstream resource is an EC2 instance. I could grab information from that upstream resource to then be utilized as inputs for my downstream creation of an EC2 instance and all the things that may come along with that. So let's jump back into Morpheus to see that it actually went through that process. So in this case, we have the resources here that we see. And so it's performing the data lookup. And so what's actually happening is it's reaching out to Cypher and then grabbing the information out of Cypher from the Cypher perspective. So let's actually take a look at what that would look like if we were to update values and how that would work. So not only during provisioning of the downstream resource, but let's say there is a change that needs to be made to my upstream resource, but I also need to ensure that it gets populated to the downstream resource and become available. So we'll come into state, we'll come and actually change the value that we have here. So let's change the file content 1. So let's go tech123 instead of just tech. So let's click next. And so it detects that there's changes that need to be made. So in this case, changes are based upon the fact that I changed the content of the file from tech to tech123, which also means the associated hash that is going to be outputted and placed into Cypher is also being changed, which then means the downstream resource should see that there's also a change because the value that it was receiving from the upstream resource has also changed as well. So let's go ahead and proceed. So we see here that we're actually updating the Cypher objects. So let's click complete. So it should run through the process to update the hashes that are being placed into Morpheus Cypher. So to take a second. All right, so we see it's going through and updating those hashes. All right, so at this point, let's see, should probably be done. Let's do a quick refresh. All right, perfect. So we now should have a new hash. So ending in 2C5F is the value of that initial hash. So let's take a look at our downstream resource. So in this case, this does not end in 2C5F because in this case, we haven't done a refresh yet. But we would go into Cypher. Cypher should show the right hash, which ends in 2C5F. So the upstream resource has been updated. It has pushed that value into Cypher. So Cypher is now aware of the updated hash or the updated value that we have from here. And so what we'll now do is we'll now go back to the downstream app. We'll go state, and then we'll go to refresh the state. It's taking a second. So it's going out, and what it's actually going to do is it's going to go out and reach out to Cypher to determine, hey, there's a new value that is available. I need to be able to leverage that. So we see that it now wants to change the existing hash to ending in that 2C5F. So we saw from a cycle standpoint that the upstream resource updated one of its values. That new value was then pushed into Morpheus Cipher. Morpheus Cipher then made that available to the downstream resource. So the downstream resource then reached out as part of the data lookup to Morpheus Cipher and saw that there was a new value, compared that to the existing value that it has or that it's aware of. And now we're seeing that the existing hash that we see does not match the new hash that is available in Morpheus Cipher. And so if I were to go to apply state, so it's going to go through the process we saw with the plan. It's going to want to update those values. All right, so it's going to go through the process of applying that update. So in this case, if we were an extra resource, we would see that there's a change being made. It would go to try to perform an operation. Additionally, if we had multiple downstream resources, each of those would perform the same sort of operation in knowing that there is a new change that needs to be made because the upstream resource in this case has been changed. So now we're going to take the appropriate action based upon the upstream resource being changed. So now we see the apply. And so if I were to run another plan, it should see that there are no changes to be made because now the current state of the downstream resource is in sync with the upstream, in this case, because the value in Cypher now matches. So there are no changes to be made because when it performed the data lookup, the value that it has matches the value that's in Cypher. So the two are now in lock state between the two. So just to recap, we had creation of the service account role. Service account role was tied to the Terraform service account. The Terraform service account is what's being utilized by the Morpheus Terraform provider to interact with Cypher, both during the write as well as the read. Though that information, which is the Morpheus URL, username, password in this case, access token could be utilized, are what's being tied to the Morpheus app blueprints. Could be Morpheus instance type as an option as well. But that's what provides the Terraform provider the credentials and method to be able to access Cypher to write as well as to read. When I instantiate or provision the upstream resource, it's going to write the data that I've defined. So that's where we talk about the explicit data I want to write into Cypher, not all of the state information. So there may be, let's say, 100 different attributes that are available, and I only want to write 5 of those to Cypher to be made available. Instead of making all 100 available to the downstream resource, I only want those 5. So that's where we're writing those 5 to Cypher. And then the downstream resource has references to the location in Cypher of which to read that data out of. And so that's where a naming pattern or pathing pattern would come into play from a Cypher standpoint of how best to handle that. And we'll talk about the value of that in the next slide of how that could also be leveraged for some security aspects. So the downstream resource now has it, and it's pulling that data out of Cypher utilizing that same TF-var secret. So now let's take a look at a more complex example that includes a number of different aspects here. So one of the things we could do to provide a more robust solution, particularly from a security standpoint, is we could in theory utilize that same service account role because it was very much pared down to just simply having access to Cypher. So that's really what we want from the service accounts. But in a scenario where we might want a TF writer and a TF reader account, service account for different permission of access, we could break those out to then be able to have for upstream and downstream resources. We would then still tie those to the app blueprints, but we would have different Morpheus TF bar secrets. One for our writer account, one for our reader account, or multiple writer and reader accounts based upon the configuration. We're still going to want to write and read data to and from Morpheus Cipher. But one of the other things we could do from a security standpoint is leverage Morpheus Cipher access policies. And so Cipher access policies within the Morpheus platform allow us to scope what it is that a given user or role has access to from a Cipher perspective. So as an example, I may want to have a dedicated Cipher read access policy for, let's say, application team A. And all they have access to are the secrets that exist in a certain part of Cipher, so a certain path of Cipher that might be accessible to it. And downstream team or application team 2 might have a different enclave or space in which they can access. So it provides some flexibility in terms of, even from a more granular level, of which resources in Morpheus may or may not have access to a given resource or object. So let's take a look at, particularly with the Cipher policies within the platform. So if we come into administration, we come into policies, and we take a look at adding a new policy, and then we go to Cipher access. So Cipher access is going to provide us the ability to be able to designate a path within Cipher. So when you go into Cipher, you'll see secret, and then oftentimes it's /something, 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 depending on the level of depth you want to provide for your paths. But the Cipher access would allow me to be able to designate that, as an example, I only want a given role, so in this case, our TB Cipher role, to have, let's say, read access to a certain path within the Morpheus platform. So maybe it's secret/app team 1. And so this would restrict the role that we have here, its access to simply this path. So it'd be anything under secret app team 1. So if there was another path that was adjacent to this, or a sibling that was app team 2, this particular role would not have access to any of the information or data within that underlying key structure. So it provides us another way to be able to segment or isolate the level of access that a given role or user may have to specific data within Cipher. So that would then allow us to be able to leverage Cipher for those upstream resources and then further delineate what the downstream resources could be able to access, to where I might have a secret that I want to write for only my team. So I'm handling the upstream resource as well as the downstream resource, but I only want downstream resources that I own to be able to have access to that secret, not additional downstream resources or app blueprints within the platform that might be instantiated. So provides a level of capability in which we can, as I said, further isolate and delineate between who can and who cannot have access. So let's actually take a quick look at an existing one that I created. So we had that secret example workspace. And so what I did was I specified that that role could have read and write access, read, write, update, delete, list access into that given space within Cipher. All those permissions were granted because we were using the same role for both the write and the read mechanism within there. I could have scoped it to simply the user, which would allow me to be able to specify individual service accounts that I wanted to grant access to for those particular spaces as well. So a number of different options in terms of the configuration that could be associated with a given service account or role within the platform. So to recap, we've walked through the method by which we can utilize the Terraform provider within the Morpheus platform to be able to facilitate those options. So certainly one of the other things to call out would be, given that what we utilized was the Terraform provider, the mechanism by sharing that information technically I don't have to instantiate or create the upstream or downstream resources in Morpheus. Because if I were to run, let's say, that code for my local laptop, I would populate the information to Morpheus as well as the credentials utilizing variables, and I could run that from my local laptop. And what would happen is that data would be written into Morpheus Cipher because we're utilizing an API call. And then on the downstream side, if I ran it from my laptop or a CI pipeline, it would still reach out to Morpheus and fetch that information from the Morpheus platform. So at its core, it does not need to be executed from Morpheus, but that's what we showcased from a capability standpoint and overall solution. So tying a number of the different components together to be able to share information from one Morpheus Terraform resource to another has been the mechanism that we've leveraged here as a possible solution within the Terraform ecosystem. So definitely appreciate the time and thank everyone for joining today.